Hello class, welcome to another edition of our studies on function. This time we are going to talk about composite function. So what is the meaning of composite? Let's take even mathematics aside and focus on the word composite. The composite means made up of two or more parts. So we can attribute this one to composite picture, that is merging two or more pictures in one frame. So composite substance is made from the combination of two or more substances. So that is what a composite means. So let's move on to the now. What is a composite function? So as we know already, a composite is made up of two or more parts. So a composite function combines two functions where the output of one function becomes the input of another. If f of x and g of x are functions, then composite function written or denoted in the form f small z dot g of x, and the meaning is the f is there, then the g of x, which is another function, becomes also the input of f of x. So the g of x is the output of another function. Then this time it has become the input of f. So a composite function is written in the form of f0 or o or 0 dot g. So when you look at this relation, we are talking about a composite relation here. The x is the input, and the input will be substituted into the function g of x, and g of x becomes the output. So the moment g of x becomes output for this one, it turns out to be the input for the function f, also written in this form. So it means that the relation from s straightforward to f will be a composite relation or composite function f composite g. So for a composite relation, what it means is that the input will be in g of x. The g of x will process the input, then it will come out with an output of g. And the output of g also becomes the input of f. Then the input of f the f function will process everything for us to get the final output. So when you look at the relation here, x is being inputted into g of x. The results, the output is g of x, and the whole g of x will also be inputted into f. So this becomes the composite relation in this particular format. Like changing two machines, first machine will process the object, and the second machine will finalizes it. So here we have to understand what a composite relation is. First, it means that first apply the g, then apply f to the results of g. That is what a composite function is supposed to be. And it is being denoted as f composite g. We can also write this thing as g is being followed by f. Good. Okay, let's move to the next section of these studies. We can also have practical understanding of composite functions. Imagine a food delivery service, and we can use f of s to calculate the food cost, g of s to also calculate the delivery charge based on distance. Then h of x is representing the total time, which will be including the preparation and the delivery. So we can write a composite function for h of x, and the composite function for h will be in the form h bracket g bracket f, then you close the bracket, which means that the food cost will be inside the delivering charge based on distance. Then the whole cost will also be inside the total time, including the preparation and the delivery. So the H represents the full delivery process in one function. We can also attribute this to a real life scenario in this form. Let's talk about online customer t-shirt business. The selling price depends on 1. Manufacturing cost, and 2. Makeup for profit. It means we can mark the shirt for profit. Yes, we are still on the online customer t-shirt business. So step 1, the manufacturing cost, which is in the form of a function modeled as f of x equal to 5 plus 2x, where the fixed cost is 5 in dollars. Then we also have the variable cost, and the variable cost depends on the color of the shirt. So 3 colors of the shirt will produce an amount of 11. How? Because the 3 will be the variable which will be substituted in at where x is. So 2 times 3 will give us 6, then plus 5 will give us 11. So it means that at the end of my manufacturing, the cost will be 11 in dollars. So I want to also sell it to gain profit. So the selling price is also modeled in the form g of y equal to 1 plus 1.50y. What does the y represent? The y represents the manufacturing cost. So it means that y here is the same as the f of x. Meaning per this model, it means that the selling price is 50% above the manufacturing cost. So if I want to know the selling price, then what I need to put in mind is the manufacturing cost is 11. That is the y is 11, the same as the f of x. So how did I get the manufacturing cost? First, I inputted an object 3, which resulted in an output 11. So now the output 11 is going to be the input or an object for G as the y. So here is it. So G of 11 will be equal to 1.50 times y, which is 16.50. So it means that this selling price was being derived from composite relation, which the x was inputted into the manufacturing cost function. Then after the results, which is the output, was also inputted into the selling price function for us to get this particular amount, 16.50. The online customer t-shirt is still what we are on right now. So step 3, how do I relate this one in the composite relation? The output 11 resulted from the input 3 into the function f of x. So if you can see here, so f of 3 is the output for 3 for f of x is 11. Then we inputted the results, the input, the output here becomes the input for the g, and that gave us g into bracket f of 3. So input 3 of function f produces the output 11, and the output 11 becomes input for the function g to produce a new output of 16.50. So composite relation diagram, g of y equal to g into bracket f of x, because the whole of this f of x is the output for the manufacturing. Then it becomes the input for the selling price. So where y is equal to f of x. So look at the relation chain here. Input 3 was being inputted into the function f of x, which resulted in an output 11. And this output becomes input into g, which resulted in the final output 16.50. So that is what a composite relation or a composite function is. Good. So important properties of composite function. So we can have f composite g. Some people would think that it will be the same as g composite f. In fact, this one is impossible. So F composite G is not the same as G composite F. The order of the function is very much important. The order matters. The function to be taken as the input and the function to be taken as the output matters a lot. Then F inverse of G of A is equal to A. F composite F inverse of B is also equal to B. So know this particular property very well. Then F composite G inverse is the same as G composite F inverse. So when you see F composite G inverse, you can find the G inverse and you can find the F inverse, and this one will give us the same as this one. Good. So F composite G, all in bracket inverse, is equal to G composite inverse, G inverse composite F inverse. So we should note this particular property very well. It's very much important and it helps a lot. Then the fourth one is if F and G are 1 to 1, then F composite G is also 1 to 1. Good. Then if F and G are onto, then F composite G is also onto. So these are the basic properties of composite function. Good. Then let's see an example here. Evaluate, example 1 is given h of x equal to 2x squared plus 3x and f of x equal to 3x minus 2. We have been tasked to evaluate h composite f of minus 2. I have two approaches to solve this particular problem. Step 1. First, I'll substitute the minus 2 into the function because the minus 2 becomes the input for function f of x. Then I will evaluate the function. We've learned about evaluation of function, yes. And the output or the results or the image will minus 8. Instantly, the minus 8 becomes the input for function h. So this one can be expressed like this. So it becomes the input for function h. Then I'll also substitute the minus 8 into the function h, evaluate it, and the final result will be minus 152. So therefore, h composite f of minus 2 is minus 152. Then let's go to alternative approach of this particular studies or example. We can also find the functional relation for h composite f of x. So here we know that f of x is the input for h. So anywhere we see x in h, we are going to substitute the functional expression 3x minus 2, which represent the f of x, into the h. So you see it in this form, 3x minus 2 all squared plus, when you come here, we have 2 minus 2x squared. So we obviously minus 2 here. The x will now tends to be the function f of x, which is 3x minus 2 all squared. Plus, obviously 3 is also here. The x will be f of x, which is 3x minus 2. We expand this one in the binomial expansion, and the results will be in this form. Then the results will be 9x squared minus 12x plus 4. Then multiply the minus 2 across group like term. Then the function, the composite function h composite f, will be in the relation minus 18x squared plus 33x minus 14. So after getting the functional relation, you can substitute the minus 2 into the functional relation and end up with the same answer, minus 152. So let's look at the next example. We have g of x equal to 8x minus 3, f of x equal to 5 plus x. First of all, we have been asked to find g composite f of x. It means that maintain the g, then the input is supposed to be f of x, and we are going to end up with this results. We are supposed to do the same for f composite g. So you maintain the f, then the g of x will be the input, then the expansion will give us this result. So when you compare the two results, we are going to realize that they are not the same. So that means that the property that we are talking about is true. Okay, so thank you for listening to this wonderful section, and I will ask you to try your hands on this particular example and send me the feedback to the channel session. Thank you.